So we've now tried a metacircular approach using Plait's Letrec for Curly's Letrec. We've also talked about the encoding of Letrec before. What I want to look at now is again inspired by an encoding, but not this encoding. It's a different encoding that says that if you have a recursive binding, that's very much like having a non-recursive binding that starts out with some dummy value, followed by an assignment to that variable, where now the variable is available and we can refer to it, and then after that actually using the variable. So this is an encoding that works if we have setbang and variables in our language. If we extended curly, put back variables in setbang, then we could have parse a letrec form into something like the setbang form. Right? So it doesn't work if we don't already have setbang in curly, and maybe we don't want to add it back into curly, but we do have setbang in plait. So maybe we should try using Plait's stateful features like setbang or setboxbang to implement letrec at the curly level. And that provides a kind of interesting trade-off. We don't include mutation in the curly language, but we do understand letrec in terms of mutation that way. So to do that, then instead of delaying values by wrapping them in procedures, we're going to make the values that we put in our environment mutable again by using boxes again. And that means that the lookup function will need to unbox instead of just using the value directly or applying it as a function. And if we make these two changes, then what do we do in letrec to take advantage of these changes? So the idea is we do need to interpret the right-hand side expression and the body expression as usual. We need to interpret them not in env though, but in some extended environment, and both of them use the same extended environment. That's what makes it a letrec instead of a let. That new environment is going to be one that extends the current environment but adds a binding for whatever our name in letrec is. So this is like the f that we're binding to a recursive function. Now what goes in this dot dot dots, that used to be the value. Of course we don't have the value yet, so what we're going to do is put a box, but we can just put some dummy value in the box for now. So like number 42. Right? And then after we evaluate this right-hand side, we get a value back that was supposed to be the value that went in this box, right? The value of the right-hand side is what we were supposed to have in the environment. So after we interp and get a value back, we need to put it in this box. So let's give this box a name so that we can refer to it later. So all I'm going to do is lift this out, give the box the name B. So I am binding in to the box B. Now I have the box B so that I can setbang it, or setbox it here. So now I setbox B after I get a value, right? This is the initialization step. I'm now filling in the actual value for the variable represented by n. And then we can interpret the body in that extended environment. I just need to sequence these two things, so I put them together with the begin. Begin will return the result of the body since it's the second expression here. And you can see this all put together in the letrec interpreter, where we have that letrec implementation using boxes as before. Our parser is generating a letrec E form directly. We're implementing the form directly. We're not actually causing interp to expand letrec to use boxes, remember, because we're using the built-in plate boxes. So this is the key part that changes here, plus of course the lookup function changes to do an unbox, and then all of our examples have to change to use a box.